Hi guys, welcome back to the part 3 of this handling netCDF files using Python tutorial series. So in this part of the tutorial, I'm going to show you how to open those downloaded netCDF files using Python. And in addition to that, I will also show you how to access the data from those netCDF files and how to extract those data from the netCDF files into a time series and how to write those data into a separate CSV file. So in order to get started, you first actually have to install this netCDF4 Python library. This library actually makes us quite easy to work with netCDF files. So I assume that you guys still haven't installed the netCDF4 package. So since we are using the Anaconda prompt, we can actually just go to our start menu and search Anaconda prompt, right click on it, and you can run it as the administrator. And once you have done that, you basically have to type this command in your command prompt in order to install this netCDF package. So I'm just going to go ahead and type pip install netCDF4 and press enter. So after a while it will show you that the package has successfully installed. So once you complete that part, you can actually you can go ahead and open your Spyder IDE. Now again, for this tutorial, I'm actually going to use the Spyder IDE, which comes pre-installed when you install the Anaconda distribution. So if you have not installed the Anaconda distribution yet, I suggest you to check out the tutorial, which I will put the link down in the description below, explaining how to install Anaconda distribution, through which you will also install the Spyder IDE. Alright, so now let's get started by importing the netCDF library. So after installing, you can actually do a quick check just to check whether you have successfully installed the library or not. So you can just check it by typing import netCDF, and when you press enter, if you did not get any error, that's actually a good indication that you have configured the library quite successfully. So now if you recall what we did in the part 2 of this tutorial series, we actually downloaded these netCDF files from the APHRODITE'S web portal, and these netCDF files actually contain temperature information, average temperature information for the Monsoon Asia region. So now let's try to open one of these files. We have the information for the year 1961 all the way up to 1966. To get started, let's actually only focus on only one file, which is let's say 1961. And using the package that we installed, the netCDF4 package, now let's try to open one of these files. Now before we do that, I would like to first navigate to my folder which I'm going to work in. So that's basically going to be the same folder to which I have downloaded the netCDF files, and I'm going to paste that path over here and press enter. And when you go to File Explorer, it will show you actually now your current working directory would be over here. So I'm just going to right click over here and then create a new Python file, and I'm going to name this as extract netCDF. Alright, so the first thing that I'm going to do is I'm going to import the dataset module from the netCDF library. So I can do that by simply typing from netCDF4 import dataset. Certain parts of this tutorial I will also be using the numpy library. So I'm also actually going to import the numpy library directly from here. Alright, now you can just run these commands by simply hitting F5, or you can click on here, and now you can see that when we run we don't get any error. That's actually a good indication. Now I'm going to directly import the file which corresponds to year 1961. So I'm going to create a variable called data, and that variable is going to be equal to dataset. This is referring to this module which we imported through the netCDF library, and my first argument is actually going to be my file path. So actually my file path is this one, so I'm just going to copy it over here and add one more backslash, and the file that I'm going to read is actually 1961.nc. so 1961.nc, and here we are going to specify that we are just going to read this file. Alright, now you can just run this command to see what happens. Alright, now as you can see, the command got executed. We got no errors or anything like that. What I can do now is actually I can just type print data, and when I hit F5 over here, you can see that this data variable, now it got printed over here. Now before actually going into these details, I just want to have a quick look of the type of this data variable. So what I'm going to do is I'm just going to type over here and ask me to give the type of the data variable, and as you can see over here, it shows that it's a netCDF 4 dataset. Alright, now let's have a look at these things that we get over here when we directly print this data variable. If we look at this line, it actually shows us some information about the file format. The file format is HDF5, and also here we can see something quite important to us. The title of this data is actually APHRODITE'S Monsoon Asia, daily temperature with 0.25 degree grids, and also it shows us the dimensions, the sizes, and over here it also shows us some variables. So before going to any further steps, let's find out actually what exactly has been embedded in this inside this netCDF file. So I'm just going to get rid of this statement over here. Now one more thing that you can do is actually you can precisely call for the variables which are being stored inside this netCDF file using this command. You can type data dot variables dot keys and if you print this one, now here actually you are able to see the different variables which are being stored inside this netCDF file. So they're basically longitude, latitude, time, TAVE and RSTN. So now let's go a bit more in depth and see what exactly these things mean. So now what I'm going to do is actually I'm just going to sort of have a look at each of these variables one by one. So let's do something like this: data dot variables, and now instead of calling for the keys, I'm actually directly giving the name of this variable. In this case it's lon. Alright, and I'm going to save this to a variable called lon, longitude. And after that, let's actually print lon and see what it gives us. So for the time being, I'll actually get rid of this one, otherwise it'll be a bit confusing. Alright, now you can see that everything that actually got printed over here is from this print command that we did just right here. So over here you can actually see it tells us some information about this longitude variable. So it says actually the units of this longitude variable is degrees east, and the long name is longitude, and the current shape is 360. So another way to actually directly access this long name, which actually gives us the indication what exactly this shortened version of the variable, you can actually just print lon dot long underscore name, and when you print this, it actually tells you this variable refers to longitude. Now if I do the same thing with latitude, alright, now let's erase this back and let's run this command again. Print data.variables.keys, because I want to have a look at the keys again. So there's another variable called latitude, so let's actually create another variable called latitude that's equal to data dot variables, and this time I'm going to specify lat here, and then I'm going to print lat.longname, and when I run this one, it actually shows me that we are talking about the latitude over here. Similarly, if I want to know more information about time, what I can do is I can actually replace this by time, and let's directly print time and have a look at the information. So you can see actually the long name is time, which was quite clear, and now the units are in minutes since 1961 0101. So it's actually the 1st of January of 1961, and the units by which the time has been specified in this particular netCDF files is in minutes. So if you start from 0, then the first day has been specified after a certain number of minutes, which corresponds to the amount of minutes per one day, and for specifying the second day, the amount of time is actually twice of that, and so on. So let's go to this fourth variable, TAVE. I'm not so sure what it means right now, but TAVE, and here we print TAVE. Okay, now let's run this command and see what happens. Now you can see actually this TAVE refers to daily mean temperature analysis interpolated onto 0.25 degree grids. Now this is actually a much better representation of this TAVE, right? So it actually means the daily mean temperature, and the units are in degrees centigrade. So now you can see how powerful these netCDF files can be, because it sort of stores all these different types of information in just in one file. So that's why it might be a bit tricky to access it, but once you know how to access it properly, things are going to get quite easy actually. And finally, I'm still actually curious to know what this RSTN means, so we will actually have a look. RSTN, what this RSTN means. Alright, now let's run this command And now you can see the long name of this RSTN is the ratio of 0.05 degree grids with station, and the units are in percentage. So this probably might not be one of the variables that we are mostly going to be interested in. For our analysis, actually it's mainly going to be this variable, which is the daily mean temperature. Alright, so I think now you got the basic idea about the structure, basic idea about the different variables that has been stored in this netCDF file. So before going to the next steps, I'll just take a couple of minutes to comment this out, because I'm going to share this script with you guys as well. So later, if you want to try it out by yourself, actually you can use this as a guide. So I'm just going to make it a bit more organized by adding some comments, and this one would be displaying the names, and over here this would be accessing the variables. And over here I'll just include a couple of examples, like we check this for longitude, and also we check this for latitude, and also we check this for our next variable, which was time. And finally there was another variable. Actually there were 5 variables, but we are only interested in the first 4. That was TAVE, the T average, Alright, now if you just run this command, you will be able to see. Now you just have to actually look carefully in order to distinguish one section from the other. So the first one is actually referring to the longitude part. So over here you can see that the long name is longitude and the units are in degrees east. And you can see that the current shape, that means the size of this variable, is actually 360. And when it comes to the latitude, the unit is in degrees north and the size of the variable is 280. And when it comes to the variable time, the shape is actually 365. So I think you can get the idea that it means that this netCDF file contains 300 information that's corresponding to 365 days. But the units are actually not in days, the units are in minutes. And finally you have another one called the daily mean temperature, where the units are actually in degrees centigrade. And the shape of that particular variable is actually 365, 280, 360. So before moving on to the next part of the tutorial, let's talk about actually what this one means. Now in order to have a look at the dimension, you can actually directly use the name of the variable. For example, we had a variable called longitude, so we can actually type in over here lon dot dimensions, and this is the dimensions of the longitude variable. Similarly, if you check for latitude, it's still going to be the same. It's still going to have a similar shape. And when you check for time, and the shape, or basically the dimensions of time, is actually also quite similar, is similar to the latitude and the longitude. But now let's have a look at the TAVE, which is the average temperature. Alright, now you can see that the dimensions of the T average is actually being defined using the time, the latitude, and the longitude. So how do you think that we can interpret this one? Now if I go ahead and run this command again, you can see that if you look over here, it shows that the current shape is 365, 280 and 360. And also if I type TAVE dimensions, you can see actually this time is referring to this 365, latitude is referring to 280, so longitude is referring to 360. So if you're actually still new to the structure of these netCDF files, this might be a bit confusing still. So I'm just actually going to use a simple, very simple diagram in order to explain to you how this average temperature data has been stored in sort of a multi-dimensional array using these netCDF files. Alright, so let's try to visualize in this manner. If I just open Microsoft PowerPoint, I'll actually be able to draw a simple diagram that looks something like this. So roughly, to give you an idea, over here it says actually the latitude. So according to our downloaded netCDF files, and as per the information over here, it says that we have the size of our latitude variable is actually 280. So that basically means is that we basically have 280 different lines which I have marked in red color. So over here actually I have only showed you 6 lines, but just because I cannot draw 280 lines, but you get the idea. The amount or the size of the latitude variable is 280. Similarly, we have 360 longitude lines. So if I color this, I'll keep the color to be blue. So these vertical lines, you can see that according to this, it says that it has the size of the variable is 360. So we have actually 360 different vertical lines and 280 different latitude lines. So how about this time dimension? So if I make a copy of this and if I move it in this manner, and if I move it again in this manner, and if I add some text like this, t equals 1 and this one t equals 4. Now you can see that when we talk about the time dimension, we actually have 365. So now you can get the idea that for each of these 365 files, so maybe I'll put an arrow like this and I will specify over here we have 365 files. So each of these files which corresponds to each day. Now in this case, as you saw over here, it starts from 1961, 1st of January. So now you can imagine that each of these 365 days means we have files all the way up to 1961, 31st of December. So this is basically how we visualize these multidimensional arrays. So that's how the data has been stored in this netCDF file, which is actually a quite efficient way to store quite complex type of data. So now I believe that you actually have some sort of a clear idea about how the data has been structured in these netCDF files. So now let's go to the next step and have a look at how we can actually access this real data which has been stored inside this netCDF file. So I'm just going to create another heading over here called accessing the data from the variables. Alright, so first of all, let's try to see how we can access this time, the data corresponding to time. So I'm just going to create another variable called time data, and that's going to be equal to data dot variables similar to this, and I'm going to specify which variable I'm going to request for. That's time. And over here, by simply putting a colon, you command the program to actually give all the available data for that particular variable. So if I say over here print time data, and if I press enter, and for the time being I can actually deactivate this print command so that whatever gets printed will not be that confusing to us. However, later I will activate those. Alright, now I'll run it again. Alright, now you can see actually how the data itself looks like. So over here you can see we have a 0, we have 1440, 2880. Now just if you can recall, you remember that the information pertaining to the time variable clearly stated that the unit which they have used in order to store the data is minutes. So that means this is actually referring to the 0th minute. This is referring to the 1440th minute. And if you just care to calculate how many minutes are there in one day, it actually happens to be 1440 minutes per one day. So this is actually the twice of that. So this actually refers to one full day, and this is the second day, this is the third day, and so on. And you might be able to guess that this could be the 365th day. So that this is how the time variable actually works. So similarly, if you would like to have a look at how the maybe the longitude or the latitude variable works, maybe we can have a look at that too. Longitude data, in that case this should be LON, and over here the variable name should be the same. Right, now we can go ahead and run this. Alright, now you can see that after the time data it starts printing the longitude data. So the longitude data is actually starting from 60.125 and increasing all the way up to 149.875. Now these are in decimal degrees. So now I think you got the basic idea of how these different data has been actually stored. And if I run this, right, now you can see that this first set actually refers to the time information. Next, and the next set actually refers to the longitude information, and finally this is actually how the latitude information looks. It starts from minus 14.875 decimal degrees all the way up to 54.625. So I think we pretty much covered all the basics of how to access the netCDF, how to read in the netCDF files and access the basic data that are being embedded inside these netCDF files. So in the next part of this tutorial, I'm actually going to show you how to extract the data in the form of a time series and save that data into a separate CSV file. I think that's actually one of the interests of most of us. So in order to do that, actually I have selected one particular point in Asia. You can see actually I have a KMZ file, which is a Google Earth readable file, which has been placed in Kathmandu. Based on the data that I have downloaded from the netCDF file, I'm actually trying to generate a time series of average temperature over Kathmandu for the year 1961, and I'm going to save that time series into a CSV file. So if you would like to actually know the exact coordinates of this location, you can just directly go over here and then go to the properties, and over here you can see what is the latitude and what is the longitude. Even though it's not that obvious when we look at it like this latitude and this longitude and latitude information is actually stored somewhere in here. For example, these are my longitude data until this point. So over here you can see actually my longitude value is 85.32. So it should be somewhere over here. You can see we have 85.6, 85.3. So it basically should be somewhere over here. And when we look at the latitude, it's 27.69, which should be somewhere over 27.69 should be somewhere over here. It's 27.8, 27.6. Now one might think that we have a very precise latitude and a longitude value over here, but over here you can see that the values do not match exactly to the value over here. So in a case like this, what we can do is actually we can find out which one is the closest latitude and longitude in terms of the data that we have over here, because these data are sort of gridded data. So we can actually find the closest grid to which this latitude and longitude data falls into. So since this is actually the introduction part of the tutorial, I'm just going to leave this script as it is, and I'm going to actually create a new script, which I think that would be much clearer for you guys as you are watching this, and also if you are trying to replicate the exercises which I'm doing over here. So let's create a new module, and I'm going to name that as extract netCDF into a time series. Alright, a bit of a long name, but that should be fine. Alright, so now let's go back to this file, and I'm going to import these two libraries again. Now you can see if I open this variable explorer, we still actually have some variables from the previous exercise. So you can actually go ahead and clear all these variables just by using this button, remove all the variables. That'll remove this one. And over here you can actually just clear the working space as well by just typing clear, and that should give you a clear workspace to work in. So similar to the previous step, I'm actually going to again read in the data from the same file. So I'm just going to create the same variable which I created before, and now you might be able to recall how we read in the data directly. Data set. First, what we do is we specify the path directly as it has been done over here, and over here we are going to state that we are going to read the file. Alright, now we can run this. Alright, now what I'm going to do is I'm going to create one variable called lat. We can actually go to data dot variables, and over here we specify the name, which is lat, and over here I'm selecting all the data from the netCDF files. Basically this step is equivalent to what we did before over here. It's basically the same thing. Just to have a fresh start, I'm going to save this again into a new variable called latitude. I can save the longitude data as well into a variable, and now let's run this command. And if you see over here, we can see that we have now two variables. These are the two variables of the type masked array. Now if I open this, the latitude, you can see actually it's an array all the way up to 279. That means we have 280 entries, I think you remember. And in the longitude, it's starting from 0 all the way up to 359, means 368 entries. And these different values are longitude values. I think that should be clear for you guys. By the way, while you're following along, of course, if you encounter some problems, please don't hesitate to type in. I would always welcome a constructive discussion, which might actually be quite helpful for the other viewers as well. So if you do have a question, please don't hesitate to comment it down below, and I'll try my best to answer it as soon as possible. Now I'm going to go and open this Google Earth file again, and now I need to extract the time series for this particular latitude and longitude. So I'm just going to sort of transfer this information back into my Python script as well. So I'm just going to create a new entry called latitude of Kathmandu, which is apparently this one. And the longitude is this. Alright, now I can run this command, and now you can see that we have new two variables, and the type is actually float because it contains a number of decimal points. And now I think you can imagine that what we need to do is we need to find what is the closest point. Let's say if you're talking about the latitude, what is the closest value to 27.697817 in, so if I roughly do it manually, it should be something around 27.69. Should be either this one, or it could be, yeah, it could be either of these, but I don't want to do this manually. So what I'm going to do is I'm actually going to create another variable called distance of latitude. Now the way normally we calculate the distance would be actually to subtract one from another. So what I can do is I can actually subtract the lat variable. I can subtract the latitude of Kathmandu from this lat variable. That means basically I'm subtracting 27.697817 from each of these entries, and I'm creating another array which actually has the same dimensions of this one. However, if we only do that, we actually will run into another problem, because some values are positive and then some values are negative. For example, over here these values are negative and certain values are positive. So instead of actually doing it as a direct subtraction, what I can do is I can actually take the squared difference. So I'm going to change this variable to have the name something like the squared difference of the latitude, which I can get by simply getting the square of this value. And I can do a similar thing for longitude as well. This one should be lon, this one should be lon as well. Alright, now let's run this command and see what we get. So the squared difference for latitude. Now if I open this one, what I get is actually the squared difference. So for example, I took latitude minus the latitude of Kathmandu. So that means if you look at the first entry, it's actually giving me minus 14.875 minus 27.697817, and that answer, it actually squares it for me, and that's the answer I get over here, 1812. I can basically add a few comments over here. This one is reading in the netCDF file. This one is storing the into the variables, and this one is storing the into variables, and this one is taking the squared difference. Alright, now we'll try to find which one is the closest point. Alright, now since we have the numpy library already handy, we can actually find out the index of, in this masked array of a squared difference of latitude and also for longitude. We can actually find out quite easily rather than scanning through it manually. You can see that over here the least squared difference should be somewhere over here. There's actually a function in numpy which we can use to do this quite easily, which is called the argmin. So as you can see over here, it returns the indices of the minimum values along an axis. So we can do that in order to quite easily retrieve the index of the minimum value. Alright, I'm going to create another variable called min index for lat. That's going to be this variable. Argmin. And similarly for longitude, it's going to be. Alright, now let's run this command and see what happens. Now if I look at this variable minimum index latitude, you can see that the minimum index is actually 170 and the minimum index longitude is 101. Now let's open this square difference latitude, and over here it says that the index is 170. So I'm just going to scroll down by looking at this index column, 170, and this minimum value is 0.0053, and so on. So you can actually do a quick test also to see if this is the minimum value or not. You can just take this variable. You can take this variable and you can simply type min, and as you can see, it actually gave us this exact number, which is the minimum number. And using argmin, we actually managed to get the index corresponding to that minimum number. Alright, now I'm going to create another variable called temp, and similar to over here, I'm accessing that variable called TAVE, which is the T average. Now if I run this command and if I type print temp, you can see that we actually get the information about this temp variable, which again has the current shape of 365, 280 and 360, corresponding to time, latitude and longitude. So now if someone wants to access the data of the first day corresponding to a certain latitude entry and a certain longitude entry, what they can do is they can simply type temp. Over here, the first entry should be the entry corresponding to the day. In this case, the entry is, let's say if you're talking about the first day, we have to enter the index of the time. In this case, the index will be the 0th index, that's actually corresponding to the first day. And when it comes to the longitude, now we found out actually over here, the corresponding longitude of the netCDF file, which refers to Kathmandu, is, sorry, this one is the latitude, which refers to Kathmandu. The latitude index, which refers to Kathmandu, is 170. So you can put 170 over here. And the corresponding longitude, which refers to Kathmandu, is actually 101. And if I print this, now it's giving me the average temperature value, because this temperature is actually stored in this variable, and we are calling the variable based on the time, the latitude and the longitude. This latitude and longitude are actually the corresponding indexes of the latitude and longitude in which these real latitude and the longitude values belong to. Now you know that after we found out the corresponding indexes for the latitude and the longitude, these two values actually not going to change, because now our point of interest is just one single point. It's not actually just moving around. So the thing that actually moves or increases or decreases is the date, which we specify by again the index. Over here, this is actually the 5th date because our starting index is 0. So that's 9.92. Alright, now let's see how we can extract. Also, if you would actually like to print the units, you can do that at the same time too. You can type temp dot units, and now it shows you that it's 9.92 degrees centigrade. Now let's go for an index which corresponds to the 364th date. You still have a value 7.81 degrees, but if you try to print the 365th date, it will give you an error because we have only 365 entries and it's starting from 0. Therefore, the highest number is 364, which corresponds to the 365th date. I think that must be clear to you by now. So now, instead of printing this one by one, let's try to find a way to extract all this information into a time series. So for that, actually, I'm going to use the Pandas library. If you have been following my tutorials, now you might know that I'm actually very fond of using Pandas, especially for this kind of tutorials. So I hope you have configured Pandas library already. If not, you can actually go to the link down in the description below and learn how to install Pandas first. So assuming that you have done so, I'm going to import Pandas as PD. And first time, what I'm going to do is actually I'm going to create an empty structure in order for us to store these data. So for example, in this case, we are talking about a single file which corresponds to 1961. So I know that that file will have 365 entries. So if we think about a table which has maybe let's say 2 columns, the first column is actually showing us the date and the second column is showing us the temperature value directly. We can first sort of create the structure using Pandas, and that structure we call as a data frame, a Pandas data frame. So what I'm going to do is I'm actually going to create an empty Pandas data frame, and later on I'm going to fill that empty data frame using these temperature values, which I'm going to extract one by one fully automatically using a for loop. Alright, so let's see how we can do that. So first I'm actually going to create the date range. Now if I go back to data dot variables, and my variable is, now I want to have a look at the time variable for a second. You can see that if I want to take the units will be in minutes, and starting from 1961, 1st of January. Actually, I can directly access this line by putting a dot over here, and if I type units, it's actually giving me this particular string. Now what I want to do is actually, instead of typing this manually, because now we are doing this exercise for one file, but later, probably in the next part of the tutorial, I want to utilize all of these files and extract the data from all of these files and sort of combine them into one CSV or maybe a one continuous time series. So if I were to do that, I don't want to actually keep on typing the years, the name of the year one by one. So I'm actually finding a way where I can directly extract it from the netCDF file itself. So now over here you can see that the year has already been mentioned over here. So what I'm trying to do is, I'm actually trying to ignore this part up to this point, and I'm going to actually just cut this part from the netCDF file itself, and I'm going to specify this to be my starting date. So how we can do that? If I just go back to the previous command, now if I specify the indexes, you see, since this is a string, my starting index is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So at the 14th index, I have the character which is 1. So I can type 14 over here, and if I go one by one, 15, 16, 17, 18, 19, 20, 21, 22, 23. Now if I put 23 over here, let's see what happens. Alright, you see that we managed to extract this part of the string, but without this one, right? Alright, so I have explained this before as well, but never mind. One more time. If you want to extract a certain character, you actually have to go one unit beyond the character that you would like to stop at. So instead of putting 23, I'm actually putting 24. Alright, now you can see that we actually managed to successfully extract the dates directly from the netCDF files information. So I'm actually going to create another variable called starting date, and that starting date is nothing but this thing right over here. Alright, so I want the starting date, and I also want the ending date. Alright, now I know actually my starting date over here would be 1961, 1st of January, and if it's another file, it'll be 1960 whatever it is, or 1970 whatever it is, 1st of January. But I know for a fact that if you're talking about this particular file, my ending date would be that particular year, 12th of December. Sorry, 31st of December. So instead of extracting this whole thing, I'm actually going to extract only this first part. In which case, I can still use the same kind of a syntax. But now instead of going all the way up to 24 over here, I think it's better to stop at maybe around, let's see what happens when we put 19. Yeah, we have this additional dash character which we don't need. So I can actually go one unit below, which is 1961. So here I'm actually going to take this one, and I'm going to add manually 1231. So if you would like to see how this would look, now just keep in mind that you can add characters to characters, you can add strings to strings. So that's why we can do this without any issue. But if I were to actually add a number over here, it won't work, because you cannot add integers, or you cannot add double or floats to a string. So you can see that my ending date is now 1961 December 31st, which is exactly what I want. This should be ending date. Alright, now I'm actually going to use a functionality of pandas in order to create the date range. And the date range can be done by pd dot date range. All I have to do is specify what is the start. My start is actually going to be the starting date, which is this, and my end is actually going to be the ending date, which is this. And now if I run this command, and if I try to find the variable which says the date range, oh yeah, I can simply type it over here, date range. You can see that I have a set of dates which starts from 1961 1st of January all the way up to 1961 31st of December, which has a length of 365. You can even open it from somewhere over here. Alright, now you can see that the date range is from 1961 1st of January all the way up to 1961 31st of December. Alright. And then what I'm going to do is I'm actually going to create an empty data frame. This is a pandas data frame. The way to create the pandas data frame would be pd dot data frame. I'm going to put 0 as the value, because right now I'm not really worried about the value, because later we are going to replace these values, and there will be one column by the name temperature, to which we will extract these values and fill it in. And for this, my index is actually going to be this date range. Alright, now I can run this, and if I open this df pandas data frame, this is how it looks. Now you might be able to imagine already that for each date I'm actually going to extract the values and fill it over here, which has currently been filled by zeros. Alright, this one I'm actually going to name it as creating an empty pandas data frame, which is not technically empty, but we will consider that as empty even though it's filled with zeros. Alright, the next thing that I'm going to do is actually I want to create a numpy array which has the same dimensions as the time variable. So for example, if I again go to data dot variables time, you can see that it has a size of 365. So now if we are doing this for multiple netCDF files, you can see that you can know that this won't be 365 all the time, because there are leap years in which the number of time steps would be 366. So I don't want to take the risk of manually typing 365, even though that's true for 3 successive years, but not for the 4th one. So again, instead of typing this by hand, I'm actually trying to use the information in the netCDF file itself, and I'm trying to extract what is the dimension of this time variable for each case. So I'm actually going to create another variable called dt and that's going to be np.arrange, which basically creates an array with single increments which starts from 0. And if I take this one and if I check the size of this, you can see that it's actually giving me 365. So I can directly use this command. So whenever it's 366, it'll automatically recognize that it's 366. Alright. Now would you like to see how this one looks? It's a numpy array. If I can run this directly, and if I open this dt, which is this, it's basically a set of integers which starts from 0 all the way up to 364, which has 365 elements. Alright, we're almost at the end of the tutorial. Now we can actually do a simple for loop for time index. This is a variable which I'm giving. If you would like to give a different variable name, you're very welcome to do so. For time index in dt, that means in here. Without going much further, if I say that print the same variable over here, what do you think it would do? It'll actually just print out all the time indexes over here like this, which is not necessarily what I need. So I'm going to get rid of this. Now before writing the command over here, let's go back to the df, the data frame, the empty data frame that we created. So if I put, sorry, it should be df. You can see actually this is how the df looks. So this is the index column and this is the data column. So if I need to select something using the index location, still this would be my 0th index. This is the first index, this is the second index. So for example, if I say df dot index location, give me my 0th index location, you will say that its temperature value is 0. That's basically it's checking this row and it's checking what are the columns available for this 0th index, and you see that we only have one data column available, and it's actually returning me the value. So if I say give me the df index location of 1, it's still going to be the same value. So what I'm going to do over here is for each iteration, now you can see this time index is actually increasing values starting from 0, 1, 2, 3, 4 and so on. So I'm going to say that df index location, put this time index over here. So similar to what we did, df iloc, in the first iteration the time index is 0, isn't it? So it'll be something like this. In the second iteration the time index will be 1, so it'll be something like this, and so on. It'll go all the way up to 365 because this time index numpy array, because this dt numpy array has 364 and 365 entries with the maximum of being 364. So I'm going to make this equal to, so for example, if I open this df, using this statement we're actually referring to each and every entry over here. So I'm saying that this entry, make it equal to basically what we just did over here, basically what we did a few minutes back. Temp, if I put 0 over here and my latitude is 170 and my longitude is 101, we need to print this out. So So I'm saying basically replace this, the existing 0 value, by this one. But now instead of putting this kind of fixed values, I'm going to put this one to be the time index and this one to be the latitude, which we identified through here. Again, don't forget we are talking about the indexes over here, not the precise, not the exact latitude values. Alright, now let's run this one and see what happens. Oh, sorry, this one should be the minimum index longitude. Now let's run this one and see what happens. You can see now it's still running and it's done. What we can do is we can actually have a look at this data frame now over here, df. Alright, now you can see that it has been filled with the corresponding temperature data all the way from 1961 up to the 31st of December 1961. Now you can even open it from here directly. Now you can see that it's a successful extraction of data for a specific latitude and longitude of our choice. And it's extracted just like this. Now I can actually save it to a CSV file as well quite easily. You can just say df2 CSV temperature. I can name this as temperature Kathmandu.csv. This one I can name as saving the time series into a CSV. Alright, now we can run this one. And if we navigate back to the place where we kept the data, you can see that it's already here. Now I can open this directly. It's a CSV file. Alright, now you can see that the data is already here. You can actually do a quick plot. And this is how it looks. You can see that around January the temperature is about fluctuates from around 5 to about 11. During June, July it actually goes up. Again during November, December it comes down, and that's basically the cycle of the temperature variation in Kathmandu, which we extracted directly from the netCDF files. So this concludes the tutorial for today. Now in the next part of the tutorial I will actually explain to you how to combine the data from the other netCDF files into either into the same CSV or into the same time series. Basically it's the same concept, and extend this time series all the way up to whatever the time for which the data is available. So I hope you enjoyed this tutorial. There were many requests asking for this particular part of extracting the data into a time series and saving it into a CSV file using netCDF files. So I hope the tutorial was quite clear for you guys. If you do have any questions, please comment them down below, because as I said, I would like to have a constructive discussion in the comments section. And if you do have any queries, I would be more than happy to clarify them for you. So I'll see you in the next one.